Hello there, my name is Boatin Rabi and I'll be taking you through general physics. So for Unit 1, we'll start from measurement, dimension and kinematics. Section 1, measurement. Let's look at the objectives of this section. The first objective is to state the 7 basic physical quantities. Objective 2, state the SI unit of these quantities. And the last objective to be able to state the differences between basic units and derived units. Physical quantities. To be able to describe a physical quantity, we first have to know what a unit is. And a unit is defined as a measure of that quantity. It is very important to be able to define a quantity in such a way that scientists around the globe will accept it in terms of definition and practicability. So let's imagine that we want to measure a distance from one place to another, and we are using someone's feet to measure the distance. How standard this thing is very absolute. So this brings about the fundamental quantities and the derived quantities. Fundamental quantity is a quantity that is very independent and it has a standard that has been set across the globe. Some of examples of the physical quantities are the mass, the length, the time, temperature, current, electricity, luminous intensity, and the amount of substance. And for the derived units, we have a lot, and they are dependent quantities. That is the addition or subtraction or division or multiplication of any of the fundamental units. So scientists around the globe, around the 18th and 19th, met at the General Conference of Weights and Measures and decided on these quantities. That's the base quantity or the fundamental quantity. They picked 7 quantities as base quantities, thereby forming the basis of what? The SI unit. And these quantities are the length, the mass, the time, the electric current, amount of substance, luminous intensity, and the temperature. And they all have its unit as, let me use a pointer. The length has its unit as what? A meter. The mass has its unit as what? A kilogram. The time has its unit as seconds. And the current has its unit as amperes. Temperature as Kelvin. Amount of substance as mole. And the luminous intensity as candela. And we should note these symbols. Let's look at a derived unit here. As explained earlier, a derived quantity is a dependent quantity. So either the combination of any of the fundamental or base quantity is a derived unit. The unit of all other physical quantities can be derived from these basic 7 units. Example of a derived unit may be frequency, force, pressure, work, heat, energy, power, electric charge, and others. Let's look at standard prefixes. In physics values or calculated values, it may be very troubling to write all the zeros, say having a Planck's constant, Avogadro's constant, and others. So we have some standard prefixes that can be used to represent very small values or large values. And you should be very conversant with all the prefixes. Say a iota, that's a big Y, having 10 raised to the power 24. Zeta, Isa, Peta, Tera, Giga, Mega, Kilo, Hecto, Deca, Deci, Centi, Milli, Micro, Nano, Pico, Femto, Atto, Zipto, and Yecto. Now let's look at the conversion of units. We know that the standard unit for a length is what? Is a meter. Depending on the value that you are writing, it may be a kilometer, a zetometer, a micrometer, a centimeter, a decameter, and others. The unit of interest is the meter, and the one attached is the what? Is the standard prefix. What if we need to convert one standard prefix to the other, or remove the standard prefix from there and get our zeros? How do we do this conversion? Let's look at unit conversion here. Should in case we have a kilometer, and a kilo is 10 raised to the power 3. 10 raised to the power 3 means it's 1,000, 1 and 3 zeros. So anytime we want to change a kilometer to a meter, what we have to do is to eliminate this K, that's the kilo, and represent it by what? 1,000. So that we will get what? 1,000 meter. What if we want to change a meter to a what? To a centimeter? We know that a centimeter is 10 raised to the power what? 10 raised to the power minus 2. So in case we have a meter And this time around, we want to bring a centimeter attached. What we just have to do is to also multiply it by what? 10 to the power minus 2, and that's we are going to get times 100. And we are going to get what? A centimeter here. There's also an easy way of doing a conversion, which we will go through in the next slide. And now, should in case we have a centimeter and we want to change it to a millimeter, the prefix m is a milli, which is 10 raised to the power minus 3. But a centimeter that we have here is already raised to the power minus 2. So what we have to do is to just add times 10 to 8 so that we get what? A millimeter. The same way is as we want to change from what? A millimeter to a centimeter, as the arrow shows, a centimeter to a meter, as the arrow shows, and a meter to a kilometer. One other way that we can go about this is still on unit conversion. So should in case in the question we are given 10 grams and we are asked to change 10 grams to a particular prefix, say a kilo, a centi, or even let's say a milli. I want us to go through very shortly how we can do these conversions. Anytime we are given a number with 8 units to change to a particular prefix, we know that a kilo is 10 raised to the power what? 3, right? A centi is 10 raised to the power minus 2, right? And you know that a milli is raised to the power 10 raised to the power what? Minus 3. Now let's go through how we can go about these conversions. You just have to just write your 10 grams here, and because we want to change the 10 grams to a kilogram, you multiply it by what? 10 raised to the power 3, that is supposed to be a kilo, and also another 10 raised to the power minus 3. And do you know that when you multiply all of this one, you should get what? 10 grams. This is because this 10 raised to the power 3 and 10 raised to the power minus 3 can cancel each other and you will get 1 when they multiply. So what we have to do next is to just move this one and replace it by what? The kilo, that's the K. So that we get our what? Our 10K, which is going to be attached to the unit, that's our gram, and still multiplied by the what? Minus 3, because that one is not changed to any. And we are still going to get this one to be equal to what? 10 what? Grams. Now, because we have the 10 raised to the power minus 3 here, we can add it to the 10 so that we get what? 10 times 10 raised to the power what? Minus 3 kilogram. And what we have here is still the same as what? 10 gram. From the explanation and the understanding you've gotten here, try and see if you can change 10 gram to 10 centigram or 10 milligram. Let's look at the standard for the fundamental unit. That is the time, length, and the mass. The SI time unit, the second, is defined as the time required for essential 133 to undergo 9192631770 vibrations. When we talk about the length, we are also discussing the distance light travels in a vacuum in 1/299,792,458 seconds, and the unit is meters. For mass, for the standard of mass, the mass of a particular cylinder of a platinum iridium alloy is kept at an international bureau of weight and measures as Sevres, that's France, and the unit is what? Is kilogram. And these are the standards, the international standards that we use. So every system that you buy and brings in Ghana, there's also a standard authority that we have in Ghana that checks the weight. And with time, when you use an instrument, you have to send the instrument to that place to be calibrated. They have their standards to there.